Okay, so in this class we're actually going to set up a database from scratch using SQL. So for this you need to make sure you've got three things already. You have to have your web server running, obviously. You will also need the database running. So you need to check that that's up and running. You need that server running. And then you will need the text file with the SQL in it that we're going to use. So I've made that available to you so you don't have to type any of this in. You'll just be copying and pasting it in. Okay, so we are going to build a database for a DVD rental store. So if you want to have a 1990s or noughties experience, you can go along to this video store and rent a DVD. And so we're going to look at the basics of a database for that scenario. Now, the first thing I need to check is that I've got my server running, and I do. So I have my Apache web server running and I have my MySQL database running. So I'm good to go. You also need then the code. So let's go create our database. So this is the code we'll need for that. The SQL code is create database if not exists retrovision. So this is saying create a database called retrovision, but only do that if it doesn't exist already. So this prevents us from overwriting the database if we run the code again, which would be a tragedy. In the browser, we need to go to localhost/phpMyAdmin. And we'll see something like this. Now you may have more or less here depending on the scenario. I'm going to click here on new, and this just shows us all our databases. And I'm going to go into SQL then here. Now it's important that you click on new and not one of these individual ones here, because then the SQL will apply just to that individual one. So we're going to go to new SQL. Okay, I'm going to paste in here create database if not exist retrovision. I'm just going to put in a typo here. I'm just going to delete the second A there in database. Make this a bit bigger. And we'll watch now what happens. There's a typo there. So when we say go, we get an error down here saying create database if does not exist retrovision, that didn't work out. Change this to database. Oops. There we go, and we run that. And ta-da! We have created a database called retrovision. We click on it, obviously there's nothing in there, but that's okay. We're going to create some tables now to make this work. But first we have to look at the design of our tables and what's going to be in them. That's an important task first, planning ahead. And so let's take a look at the design of this database and how it's going to look. So nothing strange or startling here, I think, for us. This is our customer database, not unlike the one we looked at in the last class, just a few extra additions here. So we have the customer ID, okay, and that's going to be an integer, and it's going to auto increment, you can see here, and that's going to be the primary key for this table. So that's fair enough, I think, there. I'll talk a bit about the SQL in a minute. Just look at the table for now, okay? So we're going to have a forename, surname, telephone number. I've decided to be very strict with the telephone number and decide that it's going to be at maximum 10 characters long. So we're not going to store brackets or dashes or spaces. It's going to be a string with 10 characters. So from input validation point of view, we would have to strip out all of the spaces and dashes and things that the user might want to enter there. Okay, and so I've decided that it's going to be 10 characters. It's not a number, it's not an integer. It's tempting to think you could store a phone number as an integer, but actually that would cause problems, because when you store a number as an integer, the system is only interested in the value of it. So all of our numbers start with 0, and they would actually, like the difference between 087 and 87, when they're numbers, is nothing. So if we were to store 087, it would be represented as just 87. That's actually not quite what we want. So we would be storing these characters here. I've decided that the first name can only be 25 characters long, and the surname can only be 30 characters long. This is here. So fname is varchar, so it's going to be up to 25 characters long. It can be less. And I'm also insisting that it must be entered. So you cannot have a customer entry in this table. You cannot have a record that is missing the first name. Similarly, you cannot have a record that is missing the surname. Telephone number is 10 characters. You don't have to have the telephone number. So we can store records in this table without the telephone number. Next up we have an email address. I've decided the maximum length of the email address can be 50 characters. I've also decided that this must be provided. So this database will not accept additions, will not accept a record that doesn't have the email address. I'm also insisting that the email address be unique. I am not requiring the phone number to be unique, and nor am I requiring a phone number at all, but the email address must be unique. Okay, so no two customers can have the same email address. And I'm also storing a password, so we can imagine a scenario here where, I don't know, maybe the user can log in and see what they've rented or change their email address or something. It's so we might be able to use this as the kind of the login table as well. I've decided the password must be 30 characters, and there can be no entry if there's no password. In a retail environment, maybe you have a password here, so if a person doesn't have any ID, you can ask them what their password was before you rent them something. Okay. We may add to this table. You could imagine another useful addition to this table might be the person's age or date of birth, so that you can rent them age-appropriate videos, whatever. You could see. No. So let's take a look then at the actual SQL code to create that. You can see that SQL isn't terribly cryptic or anything. So having created the database, we're now going to create a table in that database. So we say create table, if not exists, customers. So the name of the table is going to be customers. Then we have our open brackets. So just note the syntax here. We have ID, int, auto increment primary key, fname, varchar 25 not null. We've gone through all of these. Okay, so let's enter that code now in the database. What we'll do is we'll go back to phpMyAdmin and run that code. So here's one I made earlier, as they say on the cookery shows, and we'll just plug that in there. So now it's important to click on retrovision first here, so that it knows we're talking about that particular database, because you'll notice in the code itself it doesn't say anything about the database. Now it's just referring to the table. So create table if not exists, and away we go, and we say go, and it's run it and everything is fine. So now if we go to retrovision, we can see here that the if we look on structure here, we go retrovision, structure, look, we see we've got a table called customers. We can even click on customers here, and we can see the structure of the table. We click on customers here, we can get some more detail. By clicking on structure, it'll tell us the details. So this ID here is an integer, and this tells us here, this icon here tells us this is the primary key. It's a varchar, 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 varchar. Email here is just telling us that this logo, this icon here, is telling us that this must also be unique, but it's not a primary key. And we can see here that none of these may be empty except the telephone number. We may allow the telephone number to be empty. But otherwise, if we try to add a record to this table and we're missing one of the required fields, the SQL will fail. It'll be rejected by the database itself. Now, obviously, from a programming point of view, we should never be doing that. We should never be relying on the database to control what's going on, because we should have checked that already. Okay. Let's go back then and look at the code to insert some information into the table. Now, we could actually do this from PHP myadmin if we wanted, but we're going to do it in the code, okay? So we'll get this code here. So we're going to say insert into customers. And now we're specifying what we're going to insert. We're going to insert fname, sname, tel, email, password. We could do fewer. We could insert fewer things. Although obviously we would only be successful if we inserted entries that had met the minimum requirements. So for example, we could insert something with fname, sname, email and password and leave out the telephone number, and that would be acceptable. If we did less than that though, it would actually be rejected. So let's insert that code into the database. So if you just look here, the syntax, we have their values, and then we have open bracket, and then we specify them in quotes because they're all strings. If they were numbers, we would just have the numbers, and they're separated by commas. Note the semicolon there, don't forget that. Okay, that's important for the syntax. But you can see the syntax for SQL is not at all cryptic. It's clearly designed to be understood by humans. So let's go get the code for that. Copy. We go back to PHP myadmin. So again, I'm going to retrovision here. SQL. And here's the code. Let me just go. It's happy enough. Now if we go look at customers, we can see some details, okay? So now we can actually see what the table looks like. I increased the size earlier so we could see the text easier, but I have to go back down again now. And so this is the table and all of the values in it. We could manually, if we wanted, now edit these results in this interface here. We could delete things and add things. So what a lot of people do is they might actually populate their database manually, just to have some things to work with. Here the password is available in sort of plain text. We will discuss that another day and think about security and stuff. So there's our table. Nothing strange or startling there, but it's nice to see that it's actually gone in. So from this view here, we can see now that our retrovision database has a table called customers. We can go look at customers and we can see the details there. Let's keep going. What will we want next? Well, we want to have a table that holds the DVDs. And so let's have a look here at the structure of that table and how it might work. Again, each entry in the table, each row has to have a primary key, and this is going to be an integer here, and it's going to be the ID. You notice that I used ID on the customer table, and I'm using ID here on the DVD table. That's not a problem. They're separate. They're distinct. They're not the same as each other. That's fine. So this is the primary key. It's an integer. It's going to auto increment. So nothing strange or startling there. We have the title of the DVD, and that's going to be a varchar of up to 50 characters. Okay, so the string there may be up to 50 characters long. If we have a title that's longer than 50 characters, well, tough. We're going to have to truncate it. I've specified that this cannot be null. So you cannot add an entry to this table. You cannot add a record. You cannot add a row if you don't have the title as part of it. And that kind of makes sense. I mean, you can't have a DVD. What's the point of storing a DVD with no title? That's not telling you very much. Okay. Next up then, we have the year the movie was released. I would have liked to have called this year. But of course, YEAR year, that's a type in SQL. And so there's an issue there with using the reserved word. So I've just said the year. Okay? And that's of type year. I've said nothing else about that. So this is not a required field. This can be null if we want. Now ratings here is an interesting one because of course we could use a string here of maybe, I guess, up to 3 characters. So we could store 12A as character 1, character 2, character A. And we could have PG and we could have 18. So that'll be fine there. We only need 3 characters to do that. But this is a good example of a situation where you have to think about what it is you're storing, think about the possible values, and if you make the right choices, the database system can store that really, really efficiently. So if we look here, I looked up the ratings in Ireland, and you can only have a G, a PG, a 12A, a 15A, a 16A, 16 or an 18. So that's 1, 2, 3, 4, 5, 6 possible values. So actually it turns out if you've only got 6 possible values, well then this can be stored internally in the system using just 3 bits actually. Whereas storing it as a string of only 3 characters would take 3 bytes. So storing the rating information as characters would take 8 times as much space as specifying here that it should be an enum. Because there's only a number of them. There's only a fixed number of them. And so they can be stored efficiently because we know there's only 6 possibilities. It's enum rather than set because a movie can't be PG and be 12A. It has to be one of these things. Now, this isn't required. I haven't said this can be null or not null. Excuse me, but I've done something interesting here. If we add a movie to the database and we don't specify the rating, then it will go in as 18 by default. And I've decided when I'm designing the system that we want to make sure that we only rent movies. We don't rent 18 movies to kids, for example. So if someone comes in and they're 12, we won't let them take home an 18 movie. So what I've done is if the movie rating isn't specified when it's added, then it's going to default to 18. So if there's no rating identified when the movie is added, then it'll be 18s by default. And so that way then we don't run the risk of renting something to a child that we shouldn't. Clearly using a default of PG, for example, would be pointless. It doesn't give us anything. So technically we're not insisting that there is something in this field. But if when you're adding a movie to the database, you don't specify the rating, well then 18 will go in as default. So I think that's quite sensible. So let's add that and see how we go. So what I'm going to do here is I'm going to specify what this table then should look like using this code here. So we'll go back to our PHP myadmin. Again on retrovision, I'm going to say SQL. And we're going to create the table using that code. Go. Everything was fine. But then I did this earlier, so we know it's going to work. So now we go back to retrovision here and we can see, look, now we've got 2 tables. We've got the customers table. We can browse the customers table, or we can just look at the structure if we're interested. This gives us all the details here. We can go to DVDs. See retrovision, DVDs, and not a lot to say about that just yet. What we're going to do is we're going to add some values, but I'm not going to add them all in one go actually. So here I'm going to add Titanic, Men in Black, and Star Wars, and I'm going to add the title and the year and the rating for each of those. Okay? So again, retrovision. I don't have to go to the DVDs table. I just go to retrovision. I'm just talking about this database. Anything we type in here is going to apply to the database as a whole. So we're saying insert into DVDs. I'm going to give you the title of the year and the rating in that order. So this is what we're specifying here. I'm going to give you the title of the year and the rating in this order. Insert these values. We've got Titanic 1997 12A, Men in Black 1997 PG, and Star Wars 1977 12A. That's not followed about what we should call this. And we go. So now we go look at our database. We've got customers and DVDs. We can look at DVDs. And we can see these are the values that we've entered. We can also see the structure here if we want. You can see there we've got an int, that's the primary key. Title of our car is 50, the year, and then this enum here is one of these values. The year may be null. The primary key obviously can't be null. The title can't be null. The rating can be null, so that's fine, but it does have a default. Now, let's just go back and we see that we've got Men in Black, Titanic, and Star Wars. What I'm going to do now is I'm going to add the movie Central do Brasil, also known as Central Station. And I'm putting this in here. Go to SQL. But you've noticed I've not said anything about the year, and I've not said anything about the rating. So I'm going to insert into DVDs. I'm just going to give it this title. So I'm only inserting the title entry into this table. Now, obviously the primary key is going to be generated for us. That's going to be an integer and it's on auto increment, so we're grand there. So there's going to be no year specified and there's going to be no rating specified. And let's have a look and see what happens. So it's happy with that. It's been okay. Retrovision, DVDs. And we can see that Central do Brasil has been added. There's no year specified, but that's okay. That's okay. And look, 18 has gone in as the rating. We didn't specify a rating. We just specified the title. We didn't specify a rating, but 18 was put in by default, which is what we would have expected. I'm going to add that again, actually, because it's something I'm going to do in a second. So retrovision, SQL. So once again, we're adding Central do Brasil. So now we have that in there twice. So in this DVD store, we have two discs. We have this movie was so popular that we have two of them. So a customer might rent disc 4 or might rent disc 5. That's not a big deal for us, but we have two of them. So that's a choice we've made in terms of how we design the database. We'll see later. This is not an ideal choice, but that's a conversation for another day. Now, we can also update the table. So all we've been doing so far is inserting records into the table. But we can modify records that are already in the table too. And that's an important thing we'll be doing. So I'll just copy this code here and we'll look at it in the myadmin before we run it. So this is saying we're going to update the table DVDs. And this is say set the year to 1998, where the title is Central do Brasil. So this is going to go through the DVDs table, item by item, and wherever it finds a title, Central do Brasil, it's going to set the year to 1998. So let's go. Try again. Let's go. What's happening here? Sorry. Go. Okay. Don't know what that was. Let's go to retrovision, DVDs. And we can see here, look, that 1998 has been added to the year for both Central to Brazil records. Now, it may happen that you're looking for a bunch of stuff in the table, or it may just be that you're looking for one person. So if we wanted to update one person's email address, well, we'll be updating the email address in the customers table where ID equals that person's ID. And that's why we must have a primary key, so we must have at least one way of specifying a specific record in the table. No, so in the meantime, I have added a great number more movies there. And you'll see there's actually, it turns out there's some duplicates even here. So there'll be more than one copy of some movies, because some of them are that good, of course. Let's look now at the select command, and that's a very important thing that we'll be doing in SQL. So the select command generates a table that's a subset of the table that it works on. So we could say, for example, select everything from DVDs, and then this will give us the list of all of the DVDs. Now this is the list here shown before I added a bunch of them. I'll show you all the ones I've added now. We'll go in here. So we go into SQL, and we'll say select everything from DVDs. It's not crucial actually that it be in uppercase, but let's be pedantic. We go here. And you can see all of the DVDs now. So you notice we've got duplicate copies there of some of them. Okay. No, so that's the select. We can also be more specific. So I can say select the title from DVDs. Let me show you that. Again, select title from DVDs. And this time we'll just see the titles. And you notice there that they're not listed in any particular order or anything. Well, they're listed actually in the order they appear in the table. That's the point there. And we can look at some more things. You can also have this qualifier here where we can specify certain criteria. So we'll say select title from DVDs where the year equals 1997, I think. Let's see what that would do. Got to copy that so I can do something similar in a minute. So these are the ones that are all 1997. Let's just see what movies are in our database are from 2017. The Circle and Valerian in the City of a Thousand Planets. Okay. And we can do more than that. Let's have a look here at some more things we can do. We can select multiple things from the table, which makes things much more attractive. So let's do select, so we'll take the F name, the surname, and we'll do the phone number. I wonder what we call it. Was it just phone? I guess it was, from customers, like that. Okay, let's see if that's right. Did we call it phone? I don't remember. We can go, if it doesn't work, we'll go check. We didn't call it phone. What did we call it? Tell. Okay. Customers. Okay. Let's have a look there. And so here we have the fname, sname, and tel. Okay, so we can do various things like that. So we can select multiple things. We can also do more interesting things. If we go to the code here, we can say all the DVDs that are from this century. So this is in the example file. This is going to be the title and the year from DVDs. We have all the ones from this century. Let's see what other interesting things we can do. We can sort them by year. So here we're saying select title, the year from DVDs, where the year is greater than 2000. So that's what we had just before. And then order by the year. And you can see there, and then we start with 2001, and we work our way up to 2018. We could sort them alphabetically as well. Sort by title. This will give us them in alphabetical order. Now you notice there that the 50 and 50 Shades of Grey, the character 5 comes before the character B in the ASCII table, so that's how that's there first. It doesn't see it as FIFTY. If we'd entered it as FIFTY, it would be there somewhere between Buffalo Soldiers and Mute. Okay. Another few party tricks here. This time we're going to select the ones between 1990 and 2009. Let me go back to our SQL. So here we're saying select title and the year from DVDs, where the year is between 1990 and 2009. I'm going to order by the year. And away we go. So it's left out the ones from this decade and the ones before 1990. Now, SQL also has a drop command, but this is one that should be used with caution, obviously. So you can use drop to remove a table or even an entire database. So you can say drop table customers if you wanted to, and that would delete that table. Or you could say drop database sock shop, for example, and that would delete that entire database. If ever you want to use drop, you probably don't really mean drop. Maybe what you mean is you want to alter the table in some way. And there's code you can use to modify the table rather than delete it. It's unusual that you would ever want to drop a table. So far now in our database, we have the customer table, and that lists the details of the customers. And we also have the DVDs table, which has all the details of the DVDs. What we want to do now is we want to have a think about how we're going to keep track of the rentals. So here's my first crack off of this. I'm going to create table if not exist rentals. And so this table is going to keep track of 3 pieces of information. So it's going to connect the customer ID with the disk ID and a date. And then the primary key for there is there's going to be ID. So there's going to be a rental ID, and then the next column is going to have the primary key of the customer database. So essentially it's going to tell us which customer we're talking about. And then the disk column is going to have in there the value that tells us the disk we're talking about. So those are going to be the 2 foreign keys in here that connect the customers to the disks. And then we're also interested in the date that the rental actually takes place. So the ID here is the primary key. That's going to be an integer, and that's going to auto increment. There's nothing new or startling there. Now, for this to make sense, like this table is connecting the customers to the disks. So for this to make sense, I mean, they neither can be null. It doesn't make sense to have a customer entry in this database. So you have like a customer did something on a particular date, but it doesn't involve a disk. That's never going to happen. Similarly, a disk rented by no one is never going to happen. So cust and disk here must both be non-null. Must both be not null. There must be something in either of them. And then for date time, for the date, I'm using date time. So I could use date, which would just be the date, but date time is the date and time. So I've decided I'm going to be a bit of a bollocks about the rental period. And like if you rent at 11 o'clock on Tuesday and it's a one-day rental, well then it has to be back by 11 o'clock on Wednesday. So not just, so I'm keeping track of the actual time as well as the date. If it wasn't a big deal and I was just going to do the date and I didn't care about the time, I would use just the date type. But date time has both the date and the time. Now, I've decided here, if you look, that the disk should be unique, because the way I figure, we should only have one disk out. The disk can only be out once, right? Like a customer can appear in this table several times at any one time, because they can have a couple of disks out. So a single customer can have many disks. But a disk can only be rented once at a time. At any one time, the disk can only be out once. So I've decided that should be unique. And that kind of makes sense, but thinking about this table then, if we think about it a bit harder, like we have the primary key that's unique. If the disks are also going to be unique, like if a disk is only going to appear in this table once, and then do we really need the ID at all? We could probably do something like this, where the disk is the primary key. So we could say disk number 5 is rented to customer number 4 at this date and time. And disk number 12 is rented to customer number whatever. So when you have a table like this and you're having a column that's unique, that's not the primary key, you really have to think very hard, like, is that not your primary key then? So apart from the coding of tables, you need to have a think about what it is you're doing. So this is one option where the disk is in fact the primary key. And then I was kind of thinking, have I really thought this through actually? Have I thought what the rentals table is going to do? And really actually there's two ways to do the rentals table. Okay? And the right way to do it is going to depend on whether or not we can keep track of historical rentals or just the current rentals. So like, is this table going to tell us that somebody rented this disk on this date and that's all, like, and are we going to keep track of things once they're returned? Or is the table only going to keep track of the disks that are out? So if we're going to keep track of all of the rentals, even after something has been returned, well then, realistically speaking, we're going to need a separate primary key, and disk will not be unique. Because if we go back to here, if someone can rent this on a Monday and bring it back on a Tuesday, and then someone else can rent the same disk on a Wednesday, well then disk will appear more than once in this column. The same disk will appear many times. Every time it's rented, there'll be an entry in this column. So it can't be unique. So it's really a different situation. Alternatively, if we do want a table that only keeps track of what's out at the moment, so only the disks that are currently out, well then there is an argument for making this unique, But if that's the case, then there's also an even better argument for making it the primary key. And so what we could do then is when someone returns the disk, we just delete it from this table. So this will only tell us what disks are out at the moment. So depending on how you're going to do it, we're going to have a different setup, because these are two different tables doing two different jobs, really. And so it's important to think about those. So actually what I've decided to do is to, in fact, keep track of the historical information. So this disk here was rented on, disk number 5 was rented on the 1st of January, and it was also rented on the 15th of March. Obviously it was returned in the meantime, and we haven't actually kept track of when it was returned. We might not do that. But in this situation then, of course, disk cannot be unique. But like I said, if you are making something unique in a table and it's not the primary key, you really do have to ask yourself the question, should it be the primary key? The next thing we need to look at in SQL is the concept of a join. So a join combines two tables. And if we do a join with no criteria or no limits, we'll get actually what's known as the Cartesian product of the tables. So here on the left we have a table that is Tom, Dick, Harry and Mary, and we have another table, red, black and blue. If we do an unqualified join of these two tables, we'll get everything in the left table combined with everything in the right table. So you can see we have Tom, Dick, is like Tom in red, Dick in red, Harry in red, Mary in red, Tom in black, Dick in black, Harry in black, Mary in black, Tom in blue, Dick in blue, Harry blue, Mary in blue. So every possible combination is there. So that's what happens when we join two tables. Now that is not useful at all. Like, what would we do with that? Nothing, right? But we can actually make useful selections from it. So here, what we have is we've done a mad join here, where we've joined everything from customers with everything in rentals. So here we have John and Mike and Fionn, John and Mike and Fionn, John and Mike and Fionn. And you can see that the first time we have John and Mike and Fionn, they appear with the fact that customer 2 rented disk 4, which is not at all interesting to us. Okay. However, you'll notice something that is slightly useful. We are very interested in the rows where the customer ID here in this table, in the customers table, is the same as the customer ID in the rentals table. That actually tells us something useful, because we can see here that Ann Jones rented disk 4. Now, this next line here doesn't tell us anything about Mike McGrath. It's useless to us. But where the customer ID and the rentals ID, where the customer ID where the ID in the customer table and the cust value in the rentals table are the same, well, that could be of interest to us. So we'll come back to that. Here I'm selecting fname, sname, and disk from customer rentals. So this is the same join, except instead of selecting everything, I'm selecting just the first name, surname, and the disk. And again, this is not meaningful at all to us. It means nothing. It's of no use. But look here now. What happens if I select fname, sname, and disk from customers and rentals, where the customer's ID and the rentals cost column have the same value? Well, this is basically telling us then who rented what. So that's pretty powerful. That's kind of mind-blowing. So SQL can do all that for us. So let's look at this in the long form, okay? So what we're interested in, where customers ID equals rentals.cost. So where customer, anywhere where customer, so it starts pretty much with this table, although we're only selecting the name and the disk. And where customer ID is the same as rentals cost. So Ann Jones 4 is of interest to us. Anywhere else? Ann Jones again here is of interest to us, renting disk 5. Anywhere else here that's interesting? We can't see this here, but I think this is this guy, and cust 4 is the same here. So wherever this value and this value are the same, we want to select that from the table, which gives us this. So this tells us that John Smith has rented disk 2, and Jones has rented disk 4, and Jones has rented disk 5, and Jones has rented disk 10. Mike McGrath has rented disk 19, and so on. Okay. Now, look in the next slide, we're going to join 3 tables together. So without any qualifiers, without any where, this would be everything combined with everything combined with everything in the 3 tables. It would be a huge, massive table. But where the customer ID, so where ID in the customers table is the same as cust in the rentals table, and where disk in the rentals table is the same as ID in the DVDs table. So wherever you have a row where these conditions are met, we want the first name, second name, and title. And this gives us a list of the names of everyone who has rented something and the title of the disk. No, I was horrified actually when I saw this because I thought something had gone horribly wrong, but actually Ann Jones rented the same disk twice. Not the same, no, not the same disk twice. She rented the same movie twice, but it's on 2 different disks. So we'll actually have a look at that in real life. So I'm going to go here. Let's look at this one first, the smaller of the 2. So if we select F name, S name, and disk from customer and rentals, right, with no qualification at all, no constraints on it, it'll be okay. It wasn't as big as I thought it would be. How big is it? It's not too bad. Okay. But it's meaningless. If we then include only the rows where the ID from customers and the customer rentals are the same, well then we'll start to see that Ann Jones rented disk 4, Ann Jones rented disk 5, Ann Jones also rented disk 10. Now let's do the mega join here. We're going to join 3 tables, but I'm not going to put any qualification on it at all. Not going to any constraints on it. There'll be no where. So this would be pretty big, I would think. So many. So it's kind of everything combined with everything combined with everything, which again is meaningless. But we're going to select from this table only the rows where the ID in customers is the same as cust in rentals and disk in rentals is the same as ID in DVDs. And if we do that, then we will see only the titles that are rented out at the moment. And like I said, this isn't actually a mistake. We had the misfortune to have the same customer rent the same movie twice on different disks. So this SQL is pretty powerful stuff, and you could do a whole module on SQL, and people have done. But I think that's as much SQL as we need, and we could maybe even get by with even perhaps a little bit less. So don't wreck your head too much about the SQL. The next thing we need to do then, of course, is we need to use SQL in our PHP to connect to the database. And so that then is another day's work. But what I want you to do for now is to just experiment with selects in the PHP myadmin and build up the database and see what you can do with that.